In this exercise, we're going to be discussing using parameters. If you remember in Inventor, parameters are created every time you create a dimension. If we come up and look at the parameters button up at the top, we can see that for all these dimensions that make up this part, they're already in this table. Inventor's already done all the hard work for us. They've gone through, changed everything we needed it to change, and made it much easier to manage by giving us this table. Now, I did want to show you one thing from help, and I can bring up help by pressing F1. If you go into the help command and you type in algebraic operators, it'll give you the list for all the equation parameter options. You can see that very complex equations are capable inside of Inventor. You have these operators for doing addition, subtraction, divisions. We can do expressions. We basically are doing programming inside of our dimensions. The prefixes that are available, you can see all the different prefixes for mega, kilo, hecto, micro, milli. It is important to remember that these are case sensitive, just like in the real world. If you're writing this in a mathematical formula, they are case sensitive. We can come in here and look at these functions, cosine, sine, tangent, all the good stuff that you can see in a scientific calculator, you can automatically get inside of Inventor. Inventor does reserve pi and constant for the default system parameters. You can't modify those. We can take and put in unit types inside of formulas and our equations. And so let's take a look at this. If I come up into my parameters again, you can see that dimension 13 equals the center hole. That's our big center hole. So if I come down through here, you can see that the center hole equals 25 millimeters. So let's add a new one. Let's call it slot. And this slot is going to be center hole divided by 15. Hit done. And then I'll come over here to this little slot that's in this part. And I'll just type in slot. If I didn't know what the parameter was called, I could actually hit the little arrow, hit list, and just choose it from the list of available parameters. So now, if I hit finish, and I come up here into my parameters again, and this hole becomes 35 millimeters, you can see that the slot actually got larger because it grew to 2.3 millimeters. If the hole grows to 45, the hole becomes 3 millimeters. So now there's this relationship that we've built in by using parameters inside of there. If we look at the original sketch here for this part, we could even have things like this dimension equals that dimension. That's considered a parameter. We could say this dimension equals this dimension plus 5. Still equals the same thing, but if this changes, see all the rest of them change with it. We could say that this dimension, this overall dimension, is height times 2. So therefore, as soon as the height changes, you could see that that changes as well. Now in this case, it inverted my design, so I'm going to change it back. So we have all these abilities to use these dimensions, give it the design intent that we want. For example, this is some odd number here. My guess is we didn't go in here and lock this down. We just used the automatic dimension command. So I can come in here and I can say, no, this needs to be a set 35 degrees. So now if I try to dimension it, it's going to give me a driven dimension, which is fine. So you can see that we can put all this information in and we can drive it. We can say that this is supposed to be this plus 1. See there? I can put these basic formulas in. I can put really complex formulas in. I can drive all these parameters to create my parts. You can even have parameters that go through and do exceptions. So we could say, if the part grows longer than this, remove holes or add holes. If it gets wider than this, add holes. It's a little bit beyond this course, but just know that that ability is there to go through and drive using parameters, automatic creation of your parts. And remember that you're always using parameters. Every time you do a dimension, we're using a parameter. It's one of the great things about this expression display. It tells you, it shows you kind of what you're doing here, and it explains to you what everything means. So this is one of the reasons I do like to turn my dimensions over to the expression so I can see what everything is, see how it works, and how the relationships with each other work. We're building in these relationships using these parameters. So take a look at these, play with them a little bit. I will save this one out as using parameters so that you can take a look at how I've gone through and modified these parameters so that you can use them over and over again and see how these relationships work.